Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Dan salam sejahtera. Apa khabar semua? Welcome back class. Okay. Today we'll continue engineering design chapter 7. Before that, we start with Ummul Kitab and pray. Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Allahumma ftah alaina min aqwan syur alaina min hazain rahmatika ya arhamar rahimin wa bi sarri wa sirri amri wa hlul 'uqdatam min lisani yafqahu. Amin. Okay, class. Today about the configuration design. Okay, subtopic for today is about the product configuration. What's a part configuration? Number second. The product architecture design. Part configuration design. Next we have a evaluation configuration. Next we have a computer aided design, and lastly a solid modeling. Okay, what is configuration design? Configuration design is how we solve the problem. Okay, example here we have design problem, the reduce speed. We need to use the example here gear pair. Okay, and then this physical principle is like this one. This formula, the T1 omega 1 equal to T2 omega 2, and this idea is like this one. You use gear, the small gear and big gear. Okay, which one the driver, okay, drive gear and driven gear. Okay, this we call this embodiment design. Okay, we do the alternative for configuration number 1. Example, we arrange the part. Arrange the part using the verticals. Okay, sorry, this landscape arrangement. Okay, this one. Okay, then we can also arrange using the vertical method. Configuration alternative configuration number 2. Okay, we use the different feature of part. Example here we have using the spur gear. This meaning is the gear is linear line here, and also we can use the second one is example configuration using the helical gear. Okay, like this one. Configuration number 3 and 4 using the with a white teeth. Okay, more white teeth here, and you also can use the similar dimension. Okay. Example here. Okay, we have now the physical principle. Okay, we have using the force equilibrium F equals 0, and we have geometry and material. Example here with here we have an example for wall bracket configuration. This idea, this abstract element, just flat. Okay, just a straight one. We have a wall and the whole. This will call wall and two wall here. Okay, you have a hole here. Okay, using this idea, okay, we can generate the alternative like this one. Okay, different feature. Here we have this. Here the hole, we have a slot hole, and we have a chamfer here and radius at the corner here. Alternative configuration, we have a chamfer here and the slot, vertical slot. Sorry, horizontal slot. This one vertical slot, and we have a radius here. Another idea is can use the small horizontal slot and the height, the lower wall. Okay, wall part. Okay, this idea, okay, congratulation, this the summary, the idea when you have this configuration problem, either this product problem, okay, product problem, you just have some idea to how to get the alternative, okay, type of component, number of component, arrangement, and relative dimension. Okay, when we using the special purpose part, remember the special part, purpose part. Okay, this meaning we need doing the mole. You have your geometry features, arrangement of features, relative dimension, design variable, and we have also we use the standard part. Okay, standard part of the standard sub assembly, type of component, relative dimension, and design variable. Here we what they do the requirement, requiring decision. Okay, then how we obtain the best configuration. Okay, we have so many alternative or possible alternative, and then we need to select. To be selective, we need to select. Okay, here we need to do the decision. Okay. Okay, remember, using the design process, we analyze the alternative. Okay. Okay, during the how to get the best concept during the configuration design. Okay, we have a configuration product architecture. Okay, during the product configuration design, product architecture, we have two type. Okay, here integrated module or standard bus. Okay, example. Here we have architecture style. Architecture style product. Okay, and this is the scheme. Example, if architecture style is example only. Colonial. Okay, dining, living room, first floor, bedroom on the second floor. This is a colonial style. And the range, all room on the ground. Okay, no need to the spread. This is idea how we do the scheme. Okay, remember, we use the pen light. Okay, we have a bulb battery body. Okay, this item is using the element how to physical building block. Okay, how to using the block. Okay, and then from the product we can use the okay, this general. Okay, this is general product architecture. Okay, we have a standard part, special purpose part, assembly A, assembly B. Okay, remember this, I just repeated. Okay, the idea. And then what's important is a type, number, arrangement of component, standard, special parts part. Okay. Okay, this when you use the product architecture, definition is scheme by which the first functional element of product. Okay, then we can use the physical building block, same component, subsystem or sub assemblies. And then we also can use that interactive with each other. And then lastly, to perform the overall function of the product. Product can be module or integral. Example, this modular architecture. Okay, modular architecture is example. Here we have a flashlight. Module the item, module component is battery and bulb. For refrigerator is we have motor for module, compressor and switch. Automobile we have tire, radial, seat, pump, engine and so on lah. Personal computer, drive, keyboard, mice and modem. Meanings this component we can build. I can make produce this component individually. Okay. Okay, and then integral architecture. Okay, integral architecture as an example for BMW motorcycle engine. The engine and the frame is integrated. Just only one. printer case, integral snap faster without meaning the casing without the screw or extra fastener. Shaft, we are machining bearing race. Okay, bearing cup, integral the handle. Okay, this only this example. This the function is integrate between others. This meaning physical element is share function. Alright. Step for developing a product architecture. Okay, first create the schematic of function and physical element. Okay, we have two the function and physical element. Cluster element to the logic chunk to exploit standard component, exploit standard interference. Okay, full utilize manufacturing process of vendor, provide for maintenance. Number 3, sketch a rough geometry layout, identify interaction between element and refine layout. Okay, this is a step for the product. Example, okay, we have a printer. Okay, this is a enclosure printer structure, the printer cartridge, okay, position cartridge in X, Y axis, okay. We have a storage output, storage blank paper. These are some function, some component. From the idea, this using the force of energy, when this energy closure, and then the thin one is a flow of material. Okay, this one meaning this paper is going here, okay, and then another is a dot line is a flow the signal or data. Okay, from this signal data go to controller, printer, and so on lah. Okay, this is how to we okay, we cluster the element. Okay, example here, enclosure and enclosure printer structure we using as this enclosure, and this is a chassis, and then output is using the paper tray, and then we have here printer cartridge, position cartridge, position paper. The paper is under printer mechanism. Okay, when using this, the signal use accept user input, and display status using user interface board, and here we have a logic board. Okay, lastly we have a power cord is a supply and horsepower driver lah. This is example for okay, and then we have do the sketch roughly idea for the structure of the printer lah. Okay, you put the mechanism printer, chassis here, logic board, okay, and so on lah. Here better the lower side is a example here, logic board, the side view is a put roller, chassis, paper. Okay, okay, we also can sketch the interaction, okay, between the element, enclosure and paper tray. Okay, styling, paper tray to printer mechanism, vibration. Okay, printer mechanism to logic board is thermal distortion, and also chassis thermal distortion. We need the RF shielding, RF interference with the power cord. This driver, and this no connection between the user interboard and this one. Okay, next we have a configuration part, how we do the XML ADS, research source and configuration requirement sketch. Here part configuration design. Okay, example we have a special purpose part, how we do the geometry features, arranger features. Okay, this the idea from here, wall, rib, projection, filler. Okay, this idea for geometry features for the special purpose part. Okay, recall back bracket configuration. Okay, how we can generate alternative part for configuration. Okay, this from the abstract embodiment, we get the different features, different arrangement and different rate implementation. Okay, then after that we can detail configuration for sponge holder. This example, okay, prepare the configuration requirement sketch. Sponge holder is ideal configuration sponge holder. Okay, this sponge, okay, this how we this is the holder, and then we stick on the wall, and this the force interactive between the holder. Okay, step number 2, we prepare non-configuration continuous configure requirement sketch. Detail. Okay, this what we can do to prepare alternative configuration, contiguous configuration sketch. Okay, this one is okay, this part component just hold at here, that here, and this component, this sponge here, and U shape and with the radius. Okay, this is using L shape, the straight one, and there's some angle here and U shape. Okay, okay, here is idea. We put the how to define the configuration. Okay, we have some shape here. Here just straight the hole at the wall. Is you put the hole with the offset wall, and this back view. Okay, rear view. Okay, this is a front view. Front view we can see the hole. Okay, without with the offset wall. Okay, this is straight. The surface is nice. Okay, then we analyze and define. Okay, using the method design for function, design for assembly, and design for manufacture. Okay, next, how we to analyze the configuration. What is a function, what is assembly, what to be manufactured. Decide this question. Okay, will a part of product perform its function? This is some example of function. For the we can categorize as strong, stiffness visible, buckle, okay, thermal suspension, and so on. These are so many function. You can it will assemble. What do we mean by assemble? What do we mean assemble is a process handling component. Or we can bring together, okay, inserting or faceting them. Okay. This about the handling. Handling means grabbing, moving, oriented, and pressing. Handling. Design part of product to reduce the influence on handling. We can change by size, nesting, flexibility, okay, thickness, tangling, slipperiness, weighting, practicalness, and stiffness. Okay, must consider need for two-hand tool, optical magnification, or the mechanism assistant. Okay, this how we consider. Second one, insertion and fastening, meaning melting a part to another part or sub-assembly. Okay, this must item we must consider lah. Okay, next we have DFA or design for assembly. Design assembly is a set of a design practice which the reduce manpower time reduce to required to handle, insert and fasten component of product. Okay, here how we can guideline to reduce design assembly, minimize part counts, minimize level assembly, encourage module assembly, reduce standard part and so on lah. Okay, this idea, okay, when you design, okay, do not do design like this lah. The different length of the screw, the same type but the different length you try to as standard using like this one, same screw, okay, this type and same size. Okay, either you can see in the figure this one the idea. Also when you design using this one, do not, okay, another part is using the double spring, another one single spring, okay, this like this one, okay, like this cable is a different type, okay. Make sure you design one input and one output, okay. Here do not using like this one different, same color dan the different thickness but you can use the this color and 1.8 thickness and 2.4 using black color. Okay, you can see this example. Okay, like this one, socket, screw and so on lah. This idea for design for assembly, for reduce the time for assembly and then this we call is the Pokayoke this Pokayoke, very important okay. Make sure your part cannot insert this from reverse rotation and so on okay. This the pros and contrast for the FMEA method, okay, using the design guideline. Pros is positive is a fast, easy, not couple, okay. Contrast is not quantitative, can't compare alternative design Assembly effectiveness, this idea is from the Bossiot and Defru, okay. E equal to theoretical minimum time assembly, estimate time assembly, okay. We get the efficiency of assembly. DFM, okay, design, okay, spelling error, design for manufacture is a set of the practice that aim to improve the fabrication of individual part, okay. Okay, we also can use a design guideline, cost estimating method without the dimension. Okay, first, avoid design part with the thickness wall of heavy section. Design part without the undercut for the this for injection mold casting. Number 3, choose material on minimum total part per cost. Okay, this is a calculation. You can refer to previous chapter. Design external thread to lie on the part panel surface at rib for the stiffening. Okay, for the sheet metalworking, see the idea is avoid design part narrow cut out, okay. Minimize manufacturing scrap, reduce number of bending plane, okay. Keep side action feature the minimum, avoid the complete. For machining, employ standard features, okay. Standard hole, slot, chamfer, use a raw material in standard form, sheet metal, avoid shape internal corner and then special label tolerance and surface finish. Okay, that's why we can do the this final how we attain the best configuration. Okay, back the same question, to be selective we need a select. Last, we do the evaluation using the plus method, which weighted rating method. Remember the approach method. Okay, the idea is same. The how we do configuration for this sponge folder. Okay, first list evaluation criteria in the column. Determine important weightage. List the alternative along the top row. Rate each alternative on the each iteration. Compute the weightage, and sum the rating to produce overall weightage. Okay. The example. Okay, we have 6 criteria. It's a function. Okay, quick dry, dry well, dries quickly, stay clean, sponge insert easily. Manufacture. Okay. Material usage, tool cost, process cost, assembly, handling, insertion, part. Okay, this is a criteria. Weightage, we put the numbers. This total up to 100%. Rating, this we do the rating. Example with hole, and this sponge configuration rating with hole, and the second one is with bracket. With the hole. Rating A3, put 3, the same 3. Okay, dry quickly is 3, same 3. Stay clean 2. Okay, this with a bracket 3. Okay, and this sponge insert easily 2 and 4. 4 meaning the highest easily. Okay, how get this number? Is 50% times 3, you get a 0.45. Same is like this one, same. Very continuous. Put the rating for the both with the whole of with bracket, and after the final this we sum all this. Okay, we get the with the bracket is highest weightage rating 2.95, and then we choose this configuration to the our design. Okay, and then we get the best configuration. The sketch. Compact this. Okay, this is a demo of solid modeling. Okay, CAD is a data model. We have can have a 2D model. We have also can use also wireframe model, a surface model, and solid model. Okay. Then advantage of solid modeling we usually get is design intent is captured. Such whole boss, so on. We have features. Okay, we can this we have also constraint. We have a parametric, fully associate, easy to assembly. Okay, and assembly ability check, interference, motion, and move, downstream benefit. Okay, when we do our design in CAD, we can easily using the CAE, FEA, CAM, and rapid prototyping. Okay, that's all for today. Okay guys, stay safe. Okay, don't forget SOP, and see you next time. Thank you for your attention. Okay, bye.